Good afternoon, ladies, even more ladies today, and gentlemen. We are going to be starting to work on adding and subtracting rational expressions. What is a rational expression? Anybody have an idea what a rational expression is? No, it's not imaginary numbers. I'll give you a hint. Chapter 9, which we were recently working on, has to do with rational equations. Remember we had the rational equations? There'll be something like this: f of x equals 2 times 1 over x plus 3 plus 4. This is an example of a rational equation. So what is a rational expression? Now, I'll show you what it is. Here's what rational expressions are. What they are is they are expressions with an unknown in the denominator, with a variable in the denominator. That's what the definition of a rational expression is. And so we're going to identify, before starting to work on some exercise today, we're going to identify some few characteristics of what we're trying to do. Skills we try to develop here are: 1, finding excluded values, factoring in order to simplify, using a common denominator. So these are all things that we're going to kind of put together in this section. So in this case, explore, we have identifying exclude values, and we're given A. We have quantity 1 minus x squared over x minus 1. So what is the denominator of that expression? That's going to be x minus 1. And since division by 0 is not defined, the excluded values for the expression are all values that will make the denominator equal to 0. So here we're given an equation, x plus x minus 1 equals 0. So basically, setting this denominator equal to 0 in solving for x. So x is equal to 1. X is equal to 1. Now, this is the textbook definition of doing it. I got this from our textbook, but I like to articulate this situation differently. And I like to, instead of putting x, when I have excluded values, x minus 1 equals 0, I like to do it like this. I like to say not equal to 0. Why would I do such a thing?
Because that's what you're solving for.
Yeah, that's what you're solving for, but what happens is, when you put this like this, you're putting the definition in the notation. Because if I came down here and came down with x equals 1, I would have to further explain that that's what x cannot be, or that's an excluded value. When you put it in this notation here, you already communicate that x cannot be 1 in this case. So that's a preference. That's my preference, and so I try to adjust that with test. But does my preference make sense? A little bit? Okay. So anyway, we have next says begin simplifying the expression by factoring the numerator. So here we have in the numerator, and that's one thing, by the way, in class we've worked quite a bit about. Haven't we worked on factoring quite a bit in class? So what's going to be the factoring of this numerator here? Yeah, that's x squared. 1 minus x squared. That's what it is. What's going to be our factoring of this numerator here? Let me write it down here. I'll write down it's going to be 1 minus x, 1 plus x. Okay? Do you remember that? What kind of technique of factoring is this called?
Difference of squares.
It's called a difference of squares. Okay? Difference of squares. So that's just one of the main classic techniques of algebra that we've, I hope, done a fair amount of, where it's going to come up again and again, right?
Yeah, it just looks weird because the constant in front of the variable.
Yeah, and so Ben is right about that. Ben says that, and what I'm doing here, just for information, is this class is being recorded, and so sometimes when people ask questions, I won't be able to hear everything, so I'm going to repeat what people say for the, because we'll be doing this from an audience on YouTube that sees this later on, which will be people who, which will be Jay, for instance, who couldn't be here today for some reason.
Yeah. Jay says he doesn't watch the videos.
Well, he may not, but he should.
Oh, I tell him to all the time. I get on to him. That's
Thank
funny.
you for part of the interruption, but if you are attempting to use the internet, we have already been in contact with the company and we're experiencing intermittent outages. Pardon the technical. Thank you.
Well, Mr. Greiger, my internet looks good right now. I mean, I'm just looking,
5 bars or something.
yeah, just kind of looking at it. I know that's not always the case, but yeah, so mine looks good right now. I'm not saying it is, but it just looks like it's working. Yeah, but Ben, you're right. This is kind of a curveball, isn't it? And then what happens is you look at this and you're going to try to simplify, because usually in simplifying rational expressions, you're going to be able to simplify by canceling stuff.
Right.
And you look at this right here, it looks like you should be able to cancel, but you can't, right? But what you can do is you can rewrite our denominator to make this cancelable. So if I take this, how can I rewrite our denominator? I've brought our denominator over here. How can I rewrite this denominator to make this different? What can I factor out of here? Well, I can factor out a negative sign. So if I take negative out of here, negative times what equals x? Negative x. Negative times what equals negative 1? Plus 1. See, so Kim factored it out for us, okay?
Okay, so why is the constant in front of the variable? Or
Just because.
Yeah,
They can.
yeah, that's because the textbook writer wanted to, because what happens is, if you just did it in front of the variable, like normally, this would be really easy to cancel out. And so they're throwing a little curveball at you to amp your rigor a little bit. Yeah, a little bit. And but that's okay, because it gets us used to seeing things. And so now, if we went ahead and did this, how can we rewrite it to look like one of these in the numerator? We can put negative
And 1 minus x.
1 minus x. And so now, do we have something that could cancel here? Yeah, we do. So we come over to the next page here, and they have exactly that. So they have 1 minus x, 1 plus x. And here, you can cancel out, can't you, these things here. And what do we have left?
Negative 1.
So we have negative, like 1 plus x. And if we go ahead and distribute that negative sign, what do we have? Negative x minus 1. Right? So we simplify all this down, it simplifies to this. However, so and then, what can x not equal that we looked at earlier?
Negative 1.
No? X cannot equal 1. So no matter how we simplify, even if they're, because based on this alone, you can't see anything wrong with that, right? You see a domain of all real numbers. But we carry forward our characteristic of 1 is not allowed. Okay? So you gotta keep track of your exclusions as you go forward in your evaluation of these things. And then the last thing, it says, what is the domain for this function? And I think my battery is running out here. Let me get this over. What happens if I didn't recharge this thing last night like I should have, like I do, so I'm gonna see if it'll work now from here. That happens to me sometimes. Okay, I hope this works.
You know what this is.
Okay, maybe it'll work now. Okay, what is the domain for this function?
Negative 70 to 1.
To 1, union 1,
One
infinity.
and
So that's one thing we're going to do. So we're going to be finding excluded values, simplifying, factoring, simplifying, all this. So let's go to the next section here. What factors can be divided out? I'm going to go over this. Now, next, writing equivalent rational expressions. Here we have example 1, simplify the expression. And so we want to write 3x over x plus 3 is an equivalent rational expression that has this denominator, which is quantity x plus 3 times quantity x plus 5. But we only have here x plus 3 here. So what do we need to do to get the same denominator?
Factor out the x plus 5, right?
Well, actually, we need to introduce this factor of x plus 5. So we do that by multiplying both the numerator and denominator by x plus 5. And so when you do that, you have this 3 over x plus 3 is equivalent to 3x times this x plus 5 times the denominator, and the denominator x plus 3 times x plus 5. So that when we get common denominators, that's a skill we're going to have to develop to be able to do that. Okay? So let's, we're going to be given an example here to simplify this expression. So we're going to simplify this expression right here. And so we have this, in the numerator we have x squared plus 5x plus 6. In the denominator we have this x squared plus 3x plus 2 times x plus 3. So now he says, write the expression, so you write it out and factor the numerator and the denominator. What would be the factors of our numerator and our denominator here? Make it a little bigger.
3,
X plus 3.
yeah, x plus 3 and x plus 2.
So x plus 3, x plus 2. Does that look right? Yeah, that's right. Okay? And now in the denominator, we're going to carry forward this x plus 3 that we left down here. But can we factor this other thing down here too? What are going to be the factors of x squared plus 3x plus 2? It's a little hard to see, I know, for some of you.
X plus 2 and x plus 1.
X plus 2, x plus 1. Okay, that looks right. So what cancels out now?
X plus
The x plus 3 and the x plus 2.
X plus 2, right? So what do we have left?
X plus 1.
Well, what we have is 1 over x plus 1.
Yeah.
That's what I meant.
But x cannot equal what?
1.
X cannot equal negative 1. What else can x not equal?
Or negative 3.
Negative 2, or someone said negative 3 also, right? So all these are here on the bottom, they're excluded values. So we take this thing right here, reduces all the way to this, except we got to remember to carry our excluded values with us. All right? So that's what that is. Questions on that? Okay, we might get right to the, yeah, and then it has your turn, right? 5 over 5x minus 25 as an expression with a denominator of x minus 5 and x plus 1. So right here, you can take your denominator, and this can be 5, x minus 5, right here. So we have 5 up here, and that's going to cancel out, right?
That's 1.
So we have 1 over x minus 5. And what do we have to do to bring this up to speed on this? you know, we gotta multiply numerator and denominator by the same thing. And so now, what do we have left? We have x plus 1 over this thing right here, x minus 5, x plus 1. Okay, so that'll be our answer. And of course, our excluded values will be 5 and negative 1, okay? So we're going to start working on these exercises today. We'll see if I can get my...
Where did you do the first thing? Where did you 5 over 5 times x plus 5? Mr. G, where did you get that?
Get what?
The first thing that you wrote.
Once you set in the lab.
The 5 over 5 times x plus 5. Oh, did you just...
What I did here is I looked, okay, I did some different things here. I looked over here, and I saw that x minus 5, and then I saw this minus here, and so I said, okay, well, I want to see if I can get this as a common factor here. So I saw, well, if I take a 5 out of this thing here, so I factored out a 5 from 5x.
Oh, I get, okay.
Okay, so factoring, but I knew what I was going to do based on knowing what to look for. And that's something you kind of can get in trouble with.
Okay, now why did you do, I understand how we got the first one, but how did you do 1 over x minus 5? Where do you get that?
Because you crossed it out because after you get 5, you crossed it out.
Okay, okay, now I understand that part. Now, why do you
Oh, that I got.
Oh,
The,
that's okay.
why, because it had it was the 5x minus 5 and x plus 5.
Mr. G, can I run the restroom real quick?
No.
We'll make it.
Yeah, go ahead. I'm trying to find some papers for you all.
I get it until we add the x plus 1 and the x plus 1.
I think it's just because of the... I don't know.
It's not worth $5.
Lowest bid was gonna be 25, so.
I have to.
Okay, so this one would be like, oh, what is that?
Oh, no,
Something 4 and negative, I don't know which one would be the negative. Negative, oh, x, 4 and negative, x minus, x plus 4, x minus. What? No.
I'm going to try to find a couple other sheets, because I don't know why I didn't make enough copies.
What are y'all doing? What are y'all doing?
Maybe it's because
Hey, we're factoring.
I can blame Julia.
So it'd be.
Multiply together to get 3 and add together to get negative
No,
4.
I don't know, it'd be, make negative 4 would be 1 over x plus 1. Why? Oh, you cross out the 1.
I got x, negative 1.
You crossed out the
You
negative,
did.
the x minus. Yeah.
You did?
What y'all get when you factored it? When you factored it, what y'all get?
Plus 4 is negative 1. X
How
plus
does that add together to get 3?
4 minus 1.
I'm not a back.
What happens?
I
These things here.
Do you get x? I don't know what you're doing, 2 and 2.
These are links to
2
videos.
and 2? Is it 2 and 2? Because I understand how that makes 4.
You saw videos.
Hey, we're looking to the 30.
Because I factored out the x.
We'll do these live in class, the way we do it.
To get negative 4, but add together to get 3.
It's just saying.
So,
4 times 4, negative 1 is negative 4, and then you minus and add.
Okay,
okay.
gentlemen.
So plus 4 and minus 4? Plus 4? Oh, plus 4 minus 1. Okay,
And
okay.
then after this, I have,
Okay.
so I guess we would have to multiply, right? I don't know, I would,
I think when you factor, after you factor.
I think you do, it's like that.
What do you do? What do you do?
So it can't, so x equals, no, x cannot equal, x cannot equal negative 4. No, yeah. Yeah.
Hey, what do I do with the x minus 1 on top? Once I factor?
You mark it off.
Okay,
I don't know, it's all after this. And I'm pretty sure it's all.
so let me see if, yeah, I still have power, okay, still working.
Yeah. So now I just have x plus 1.
So now what we're going to do is we're going to go to your exercise sheet that I gave you here, evaluate homework and practice. Do you have that?
Yeah.
Okay. Now, given a rational expression, identify the excluded values by finding the zeros of the denominator. So for number one, I got a choice. I can call on somebody to do it, or I could, you want to do that one?
What? No, man, you can't do that.
Okay.
No, you can't do that.
I do it. I
No,
can do
you
it.
Okay, let me show you.
Yeah, Ken can.
What you do to find excluded values, you set your denominator, just like we did in the exercise sheet here. So we put x squared plus 3x minus 4. We set that to not equal to 0. Does that make sense? Okay? Then what's our next step here?
Factor now.
So factor here, find the factors, and whatever factors are. Now, will these things always be factorable? No, not always, okay? But right here, I could act on the hope that, hey, they're obviously expecting me for it to be factorable, probably, right? So what are the factors of this thing down here?
X
plus 4,
plus-
X plus 4, X minus 1.
Yeah.
Okay, good job. I heard several people say it at the same time. Then what do we do with these two factors now?
Don't.
Okay, now we do.
Cross it out.
Okay, so now we do. And then you.
Cancel out.
Cancel out X minus 1. X minus 1.
Yeah. No, he said no.
That's nice. We're on next one.
Not yet. Now here, not yet. Okay, look at the instructions. We're going to find the zeros of the denominator.
So do you make put in a fraction form?
No, it's 0, so x
Oh
can't
my
equal.
So x plus 4 cannot equal 0, nor can x minus 1 equal 0. So what you're doing is you're taking these factors and you're setting one factor to not equal to 0 and the other one to not equal 0. So x cannot equal negative 4, nor can x equal 1. Now I had several of you running ahead with it, that they're limiting to it, but if you actually change this over here to x minus 1 over x plus 4, x minus 1, you would be able to cancel, right?
Yeah.
And you'd be left with 1 over x plus 4. But we're being asked really just to find the zeros of the denominator. So this is sort of a scaffolding step for later things. So I want you to do is do number 2, and I'll call on somebody. I'll call on somebody for number 2 here in just a half a minute.
Oh, wait.
You get it?
If you ever signed up to remind.com, you know what that is? It's a service, it's a website, but what they do is they text, like, have over here where it says I have 2 honors. You text, how do you sign up to Remind? Is it to 8?
Oh, wait, this is.
They'll show you how to do it, but that Algebra 2 honors class, and I send out videos every night from class. So you'll see them, so they'll be right to your phone, so in case you miss that or something like that, you'll have
We
it.
only have 8.
So I recommend, you ever signed up for that before?
No.
They'll show you how to do it.
Thank you. Yeah. Oh, I hope it lands on me, Mr. G.
Do you?
No.
No.
I mean, I think I did something.
Mr. G, can I not?
If x is 0, it's like here.
Set your denominator to not equal to 0, like the other, like problem 1.
Then you get 7.
And then solve the same thing. What property of algebra allows you to do this, to set each of these equal to 0? Okay, it's called the zero factor property. What is zero factor property? What is a zero factor property?
That you can set anything you want, pretty much to 0, as long as you.
Okay, zero factor property is anything times 0 equals 0. That's all it is. And so therefore, this will be not equal to 0 if either of these is not equal to 0. So that's a zero factor property of algebra. Okay? Now let's find the victim for problem 2.
Problem 2? Okay,
Shuffle a few times.
Shuffle twice.
Why did it?
I hope
It's
so.
because
I can do this one, I understand this one.
if it's me.
Yay.
Oh my gosh. Oh, Mr. G, I don't
Let's
know.
go, Eddie!
Not even do it, should be fine. Should be
I
fine.
get it. I don't get anything.
So let's go here. So the first thing we're going to do, Ed, just like this one here, we're going to say x plus 17, that's not going to be equal to 0.
Okay,
Okay, what next?
I don't know.
Okay, we have two factors here. We have x, so x cannot equal 0. And what's our other factor?
X plus 17 cannot equal 0.
X plus 17 cannot equal 0. So what can x not equal?
Negative 17?
Negative 17, she says hesitatingly. No, but that is correct.
Oh, I'm done.
Good job, Eddie.
Thank you.
See, I understood that one.
See?
Now I don't understand any of it. That was the last chance I'll have.
So anyway, what we're going to do is go to 3 and 4, and just kind of finish with those today probably. That wasn't so bad, was it?
No? I think we're gonna run out of time.
We'll do 3 and 4. We'll be able to get to 3 and 4 though. Okay. What happens is, number 3, it says write the given expression as equivalent rational expression that has the given denominator. And here's the expression, and we want to get our denominator equal to x cubed plus 8x squared. How do we do that? What can we do? Let's factor this thing down here, this denominator. So what's our common factor in here, in this denominator? X squared, right? So we have x plus 8. And so now we can say, okay, so we have this x minus 7 over x plus 8. What do we have to multiply our denominator by to get this?
Wait, why did you write?
X squared. So if we multiply both the numerator and denominator by x squared, then what do we have? In the denominator we have x cubed plus 8x squared. And what are we going to do with this guy up here? We can redistribute, right? So we get x cubed minus 7x squared. So this is going to be our number 3 rewritten with this denominator here.
Was that it?
So that's it, yeah. Now, one thing I don't like about this book is the book will a lot of times go from one problem, like they'll have an odd number problem, the next one will be a similar degree of difficulty, odd number to the first odd number problem. This book is not a lot of times that way. And so to get this expression of 3x, is that 3x cubed? Over 3x minus 6, how do we get that to equal that denominator? What can we do? Okay, what we can do is we can take this 3x, minus 6, and what's our common factor for this? 3. So you have 3 times x minus 2, but we're trying to find 2 minus x. So what else can we do? Yeah, we can factor out the negative. If we factor out the negative, we're going to get negative 3 times negative x plus 2, which is the same as negative 3 times 2 minus x. Okay, so now we've reduced it to this form here. So now in rewriting the expression, we put 3x cubed, and in the denominator, we put down this negative 3, and we put this 2 minus x, and we want to get this denominator here, so what do we do with this? Multiply by x squared plus 9 here, and likewise x squared plus 9, and what cancels out? Well, it will, but we're trying to cancel this out. We're trying to leave it in this denominator here. So that this will cancel out, and the negative will come up here. So what we have is negative, I'll put equals, we have negative x cubed over 2 minus x times x squared plus 9. And then in the numerator, we have x squared plus 9. And then we can distribute these things in the numerator. And when we do that, I'm going to extend here a little further. We have negative x to the 5th minus 9x cubed over 2 minus x times quantity x squared plus 9. And so that's a little bit of work, isn't it?
Yeah, I feel like someone made that marker on purpose.
Yeah, so we're going to leave it there. Just keep your paper with you, and we'll just resume tomorrow, okay? Thank you.
Like a single joke.
I want to show you something else.
Figure out this.